Lesson 70, terminating and repeating decimals. So today's lesson is going to build off of the lessons that we have done so far in changing fractions into decimals, but of course there are going to be a few new things to learn along the way. So we're going to start on the left-hand side of the screen with the mixed number 1 2/5. And what we're going to want to do today is change that into a decimal. Now, what's new about this is before we have only ever looked at fractions, not mixed numbers, so we haven't dealt with the whole numbers in the front yet. So we're actually going to just leave the whole number. We're going to ignore the 1 for a minute and just focus on the 2/5 instead. All right, so you know how to change a fraction into a decimal. One of the methods is to do division, and that's the one we're going to do. So you take the numerator, which is 2, and you divide it by the denominator, which is 5. 5 doesn't go into 2, so we have to add a decimal 0. Now we can think to ourselves, how many times does 5 go into 20? It goes 4 times. 4 times 5 is 20, and we end up with a nice remainder of 0. So 2/5 is the same thing as, oops, somehow went to eraser there, 0.4. All right, and we have done that. That is review. Now, the only extra thing we have to do is think about that whole number. And it's actually very, very simple. The whole number in a mixed number is actually just the same thing as a whole number that would be in front of a decimal. So all you have to do when you have a mixed number is take the whole number and put it in front of the decimal. So 1 2/5 is equivalent to 1.4. That is our final answer for what does 1 2/5 equal in decimal form. So no matter what the number is that's in front of the fraction, you just take that number and you put it in front of the decimal. Very, very simple. Now, what 1 2/5 is an example of a terminating decimal. And terminating is just a fancy math way to say that this decimal ends. We had a remainder of 0 over here. We don't have a whole bunch of numbers coming after this 4. It ends at 1.4. All right, so terminating means it ends. And those are the type of decimals that we've been working with so far. We haven't had anything different yet. But for today, we're going to take a look at a decimal that does not end. It is not terminating. So let's take the fraction 1/3. Let's change it into a decimal by doing 1 divided by 3. 3 can't go into 1, so we have to add on a decimal 0. So we add a decimal up here. 3 goes into 10 3 times. 3 times 3 is 9. We subtract. We get a remainder of 1. Since we have a remainder, we have to keep going. You can keep adding those zeros. So now we've got 3 into 10 again. Goes 3 times. 3 times 3 is 9. We subtract. We get a remainder of 1. Bring down another 0. Oh, we've got 3 into 10 again. Oh, goes 3 times. 3 times 3 is 9. We end up with the same remainder of 1. We're going to bring down another 0, and I think you can see where this is going, grade 6. No matter how many division steps you do, you're going to keep ending up with a 3 up in your answer. So what this is called a repeating decimal, which just means one or more digits keep appearing in a pattern. So if I were to keep dividing, I would still be getting 0.33333333, and it would never ever end. Okay, so this is a repeating decimal. It doesn't end. You don't end up with a 0 in your remainder. So it just keeps going and going and going. Now, in math, we have a way to represent these decimals that keep going and going and going without writing down all of the digits of that decimal. So there's a bit of a shortcut we use. And here is the shortcut. So we're going to take that same decimal, 0.33333, repeating. And all you have to do is rewrite it and then put a little bar on top of the digit that repeats. That little bar signifies that that 3 keeps appearing again and again and again and again and again. These are equivalent. Okay, so all you have to do is put a bar above the digit or digits that repeat. So let's try another example. Let's say you came up with the decimal 0.2777777, and it kept going and going and going. Well, you could rewrite that as 0.2, and since the 7 is the number that repeats, you put the bar above the 7. Now here's a word of warning. Be very careful that you don't accidentally put the bar above the 2 and the 7. Okay, because what that would be representing is 0.272727, which is a different decimal than this one. Okay, so X, I'm going to erase it. Don't do that. Make sure that you put the bar just above the digit or digits that are doing the repeating. So if there's one in the front that is not repeating, it doesn't get that repeating bar. And it can be even more than one digit that repeats. That's why I said digits that repeat in a pattern. So here we have 3.1231231, and you could assume that the next digit is going to be a 3. So what you do is you write out the digits that repeat. In this case, 123 repeats, and all of them get a repeating bar. So basically just the rule of thumb here, grade 6, is to put a bar over the digit or digits that are doing the repeating in order to write it down. Now, one more thing before I end this video. For this lesson, there's a large section where it says use a calculator, and most often I say ignore that and don't use a calculator. But for this lesson, I'm going to allow you to, because the point of this lesson is really to get the hang of using those repeating bars. Okay, so when it says use a calculator, you may go ahead and do that. So if you have any questions, let me know.